Hi everyone, welcome to my cyberspace. We continue our Power BI project on healthcare stroke data analysis, and we're just getting started into what are the process we need to do before going right into visualization, because that is one of the most important things to do. If you're new to this channel, welcome and subscribe to my cyberspace because it really helps the algorithm to show this video to more people. I'm sure you've done that. Thank you. So let's continue, and in case this is the first video you're watching, kindly watch the previous videos in the series, so it's going to help you to stay up to date and how we got the data sets we'll be using. So I have this data already, which I'm just going to open up healthcare stroke data. I created a copy for myself already, and before you jump right into analysis, most of the things you want to do is to know what are you solving. You can't just go to Power BI and the next thing is you just keep picking up visualization that do make sense. In the last video I spoke about that some variables are important, some are not, and all of that, and I said what's the focal variable. So the focal variable here is stroke, and we can try to think of possible question. We also know that I do have like a description here of the variable, so we can look at it from here and think intuitively what are the things that are associated with stroke. So one question we can ask ourselves is does gender vary by does having stroke vary by gender? So this is examples of questions to ask. So it's basically, does stroke vary by gender? So you might not be thinking of it initially, like you might not come up with very simple great questions as this. It comes with practice, but there's something I want you to understand as I come up with my question, so that you can know of the thinking process. So I said, does stroke vary by gender, or does having stroke, let me even make it like something more layman, does having stroke vary by gender? So having stroke vary by gender. So one of the things that you will need to know is when it's a categorical variable. Categorical variable for context is variables that their levels are text. Like for example, let me show you a numerical variable. This is a numerical variable. We see all of these are like 22, so this and this, so these are numerical variable, this are numerical variable. So these are text, mostly categorical variables, but let's go. It's not all the numbers that are numerical variable though. So if a variable is like a category, is in categories, so most of the time, most of the language you will see is, does it differ, does it vary? Those are the language you will see as you come up with your question. Say, so does having stroke vary by gender? So just think of it. So another question we can ask similarly to this is, since we have gender, we can have another category. Say, does having stroke vary by say maybe resident type? That's what we do. So does having stroke, still the same, does having stroke vary by resident type? So let's do that, vary by resident type, right? So that's one thing that we are doing. So that's one way. And next thing we could do is we could try to think of also for age, maybe age and stroke, right? So when it's now a numerical variable, you will see the way I would phrase the question. So I could phrase this out like something like, what's the association between age and having stroke or not, or stroke status? So that's one, right? So or it's another way I could phrase this question is, does the chances of having stroke increases as an individual grows older? So we want to see if this data actually proves this. So if we make this in this question, we are making it more like directional, and this one is like we are giving it more open-ended, like is there an association, or if we see like a pattern and all of that. So you see, like for numerical variable, I'm asking, the way I ask is a little bit different. I will not say that does having stroke vary by age, because, or does it differ by age, because age is not like a group in itself. Age is like age is numerical, so it doesn't differ. You can't say something that's like numerical differ by itself. So most of the time it's like, does it increases or decreases? If it's a numerical variable, when we say categorical variable, we use vary, or if it differs. So let's come up with like 2 more questions, and we would. So this is just one question. This is one question here. Either way, this is 2 questions. So we put this 1, and this is 2, second question, and this is third question. This is a third question, and this is, let's come up with another one. Then we can jump right into analysis and maybe just pick up like spontaneous questions as we analyze. So one way we could also think of it, so this is another numerical variable. So we use BMI and stroke. So let's just still write the same one. It's just going to be, what's the association between, let me copy this and just put it as BMI. Having just the association between BMI and having stroke or not. Does having stroke increases as in BMI increases? So let's start with that. So one of the things you need to also notice, the reason why I group this is that this is a categorical data. This is a age is a numerical data, and age is also and BMI is also a numerical data. So the question is stroke a categorical data or a numerical data? If you think about this, having stroke is, and let's go back to what we have here. Having stroke here says it's if the patient had a stroke is 0. If the patient had a stroke, and 0 if not. Most of the time when something is a dichotomous variable, like when I mean dichotomous variable, it has like 2 levels. It has 2 levels. That's yes or no, and is the variable of interest. You can represent it as either like you can represent it as either 1 or 0, or you can either represent it as either yes or no. So when you represent it as 1 or 0, it sounds as though it's a numerical data. But when you present it as like yes and no, it sounds as though it's a categorical data. So going back to what we have here, imagine they had used, instead of 1 as add stroke and 0 and no, instead of they just wrote yes, no, yes, and those that did not have stroke as no. You might think of it that, oh, this is a categorical data, but now that it's like 1 and 0, you're thinking of it as a numerical data. But in the real sense, this is a categorical data in itself. But the reason why using 1 and 0 might make more sense is if you are doing some, let's say, logistic regression or a little bit something more complicated, you might want to have this as 1 and 0. You could also have it as yes and no, and it will still work. But what we are doing is, in our question or in the type of analysis that would make, we are thinking of this as, we are thinking of having stroke as a categorical data. So what we have here is 2 categorical data. So this is also 2 categorical data. This is 2 categorical data, and this is 1 numerical and one categorical. So the question is, so what's the numerical, what's categorical? So we know obviously having stroke or not is a categorical data, and the other one is also the same thing. So in the next video, we are going to load in this data in Power BI, and we would like try to do some transformation. And because what we have here as 1 and 0, it might not look nice if when you're running a chart and you are seeing 1 and you're seeing 0. So we're going to show you how to make your data look clean and better. So stay tuned and watch out the next video that I'm going to be talking about how to load in this data in Power BI and how to do some analysis. Thank you. Ciao.